This lesson includes a brief introduction of the structural use of steel fiber reinforced concrete. It was in the 1950s when the first studies on composite materials, and more precisely when the works of Romualdi with Batson and Mandel in 1963 and 64 had higher impact and boosted new research in the field of steel fiber reinforced concrete. Nevertheless, the use of such material has been limited due to the absence of experience and expertise and regulations in such beginning. That is to say, the use of fibers in structural applications in civil engineering comprises a practical experience of more than 50 years nowadays. And based in this modern concept of fiber reinforcement and with the backup of the recent regulations have promoted the use of fibers, and this has been widened, and especially with these steel fibers. Even though the wide range of benefits and possibilities of steel fiber reinforced concrete had not been still completely explored, the number of applications are numerous, and this has been previously explained in other lessons. Among them, some of the most important are applications in which the stress distributions are widely variable or not well defined, like pavements, tunneling, or slope stabilization. Highly reinforced sections with the resulting difficulties to cast concrete. In this case, fibers can reduce the reinforcement required and allow a more adequate design. Elements with low amounts of reinforcement. In this case, fibers can totally replace the minimum reinforcement amounts and are especially appropriate if reinforcement orientation or arrangement is not obvious. Thin elements, where with tolerances for placing the main reinforcement bars can significantly affect the value of effective depth. And elements with 3 or two-dimensional stress distributions. The use of fibers applied to concrete in Europe is codified in the European Regulation EN 14889. This regulation divides the fibers into two main branches, those which are made of steel and those that are based on polymers. This lesson will be dealing with steel fibers, which are mainly formed by carbon steel, although it also includes stainless steel and galvanized steel. Among all the possible ones, the most important are those that are obtained from cold drawn wire, from cut sheet, from melt extract, or those shaped from cold drawn wire, and finally those nilled from blocks. Independently from its raw material and regarding its shape, there is a great variety of shapes that provide different improvements to concrete. In the top left corner, steel straight fibers can be seen. In the top right corner, fibers with sinusoidal shapes can be observed. In addition, fibers of different diameters and lengths can be seen in the bottom left corner. Moreover, straight fibers crimped with crimped ends can be perceived in the bottom right corner. The main characteristics that define the steel fibers are, in the first place, their length, that ranges from 10 to 75 millimeters. It has to be highlighted that the longer the fiber, the more difficulties encountered during the concrete mixing. And in this regard, it is more important to consider the aspect ratio. This is the relation between the length and the equivalent diameter of such fiber. This diameter usually varies from 0.5 to 1 millimeter. The tensile strength of the fibers depend in the type of steel that has been employed in their manufacturing. Such tensile strengths might have great variations also, from 500 megapascals to 3000 megapascals. Regarding their strain at rupture, the steel fibers, similarly to other structural members made of the same materials, can be considered as ductile. In addition, the volumetric fraction that is commonly employed in concrete ranges from 0.25% to 2%. For example, by adding 26 kilograms or 40 kilograms per meter cube of concrete of steel fibers, the behavior that can be seen in the blue and red curves respectively can be obtained. Such behavior is obtained in a 3-point bending test performed in notch samples. This behavior observed shows the following improved characteristics in the material: a controlled cracking that provides ductility to the material and subsequently a safer structural element. In addition, the fracture energy of the material is greatly improved due to the bridging of the fibers in between the faces of the cracked plane. Moreover, the tensile, flexural and shear strands are heavily enhanced. Finally, the presence of fibers can prevent concrete from spalling when subjected to blast due to the great amount of energy that the material can absorb. Thank you very much for your kind attention.